Today I will be explaining the peripheral nervous system, specifically the autonomic nervous system. So the autonomic nervous system consists of involuntary organ functions our body does, while somatic is voluntary organ movements and muscle movements. So specifically for autonomic, it is divided into two divisions, sympathetic division and parasympathetic division. So in sympathetic division, it is made up of traits such as mass activation, which means that they alert or activate many effectors at once. This is because it takes action during emergencies or movement-to-movement regulation, which is why it says fight or flight right here. It involves like reflexes or scared or fright, and it undergoes signal convergence and divergence, which I'll explain a little bit later. And then parasympathetic involves selective activation, so they're opposite, but they work together on the same organs to balance our body functions inside. And selective activation is when preganglionic neurons are long in synapse, with postganglionic neurons are close to effectors because the purpose is localized and discrete stimulation. So parasympathetic is known as rest and digest because it's calm and chooses its organs of selected organs. So it does like when you sleep or digest something. Those are a few examples. So here are some diagrams to help visualize signal divergence, which I think like to diverge or like to split. So first we have one short preganglionic neuron, which splits into 1, 2, 3, 4 multiple other postganglionic neurons, which go to different effectors. And then for signal convergence, it is coming together, like the CO reminds me of coming, and it has multiple signals, like short preganglionic, which come together and form one that goes to the effector. So sympathetic does both of these, or either or, while parasympathetic sticks to selective activation. So it's very 1-2 segments. It's not to a bunch. It's like sought out and like welly synthesized, because sympathetic is more of like a reflex, fast reaction, while this is more slowed down and direct. And it includes small signal divergence. And looking at their pathways, they both start with the same preganglionic neurons and secrete ACH, which is acetylcholine, and this part of the preganglionic neuron is always excitatory. And then through the synaptic cleft, they don't touch, they release ACH they both have nicotinic ACH receptors. So in the postganglionic neurons, which are these ones and these and these and these, this is where it all differs. So looking at parasympathetic in the postsynapse, it continues to secrete acetylcholine, which now either has an excitatory or inhibitory effect. And it adapts to only one receptor, which is muscarinic. And so an example of this is heart rate. So if our heart is beating really fast, it will inhibit it and slow it down. Now in postsynaptic for sympathetic division, it secretes norepinephrine or adrenaline or epinephrine, which attached to adrenergic receptors, which have second messengers, which are beta 1, beta 2, alpha 1, and alpha 2, which amplify and relay signals furthermore to certain lungs, organs, heart, etc. Yeah, so in conclusion, symptomatic and parasympathetic work with the same organelles, but they have different, one is fight or flight and the other is rest and digest, but these opposing factors balance one another out. And just to remind you, it's autonomic, so it's involuntary, while somatic is voluntary. Thank you.